4.6, Scatterplots. A scatterplot is a graph used to determine whether there is a relationship between paired data. Scatterplots can show trends in the data. The first trend would be a positive correlation if the dots are closely related and going up. The second one would be a negative correlation. And the third one, it doesn't have any correlation at all. It doesn't look positive, it doesn't look negative, so that would be relatively no correlation. Describe the correlation of the data graphed in the scatter plot. We would say that this is trending upward, so this would have a positive correlation. We can see that the data is going downward, so we would say that this one has a negative correlation. Swimming speeds. The table shows the lengths in centimeters and the swimming speeds in centimeters per second of 6 fish. Make a scatter plot of the data. Here's my X, here's my Y. All right, our X's are all positive, our Y's are all positive. All right, that looks better. And what are we going by from 40, 50 to 150? And we will plot that data. When X is 37.8, we get 148. When X is 19.2, we get 47, 21, 88, 26 and 131, 26.8 and 98. Describe the correlation. Well, you would want to have even amount of points on both sides as much as you could. Though it does seem like it's trending in a positive direction. Describe the correlation. I would say positive correlation. The next example is using a line of best fit to model the data. We're going to start by making a scatter plot of the data. We're going to let 1990 be 0. So we have 1992, 1991, 1990. Let's say that 1990 is going to be 0. When X is 0, these are your X. Active clusters would be Y. 1991 is going to be 1. 92 is 2. Making sure they go in order. 94, 95, 96, 97, 98, 99, 2000. If there were any numbers missing, I would need to make sure that I fill in the appropriate number. They're all here, so I can just go right in order. 3, 4, 5, 6, 7, 8, 9, and 10. And we're going to plot these points. I've created my graph. And you can see that I've gone starting at 20 and I've gone by 2s. I have a broken graph here. And then I'm going by 1s, 1, 2, 3, 4, 5, 6, all the way up to 12. And I'm going to plot those points. So we have 222, 324, 427, and so on. Plot all your points. Step 2, decide whether the data can be modeled by line. The data is trending upward. I would say that we could create a line. Step 3 says draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. I need to have just as many data points above the line as below the line. Here I can see that I've only got one below the line, all the rest of them are above. 1, 2, 3, 4, 5, 6. That leaves 4 below. 1, 2, 3, 4 above. Those look like they're on the line. 1, 2, 3 are above. 1, 2. That's pretty close. All right, so it says that you should have just as many data points above the line as below the line. It's pretty close. 1, 2, 3, and then 1, 2, 3. That's pretty close to a best fit line. This is called the best fit line. It best fits our data. And now we're going to create an equation of that line. We're going to pick 2 points that are on the line, and then we're going to write an equation of that line. Let's go with the points 324 and 842. The first thing that we need to find is our slope. Subtracting our y values over subtracting our x values. I started with the right and went to the left. And I did the same thing for my x values. Started at the right, went to the left. Our slope is 18/5. And now we're going to use the point slope. Let's go with 324 and create that line. We have our formula, the point slope. So y minus y1 is 24 equals my slope times x minus 3. And write an equation using 2 points on the line. The points do not have to represent actual data pairs, but they must lie on the line of best fit. So it doesn't say what form to have your line in. I think that I will clean this up a little bit though. All right, after doing the distributive property, adding 24 to both sides, common denominator, negative 54/5 and positive 1/25, we get y equals positive 66/5. This is for data, so sometimes it's just cleaner algebra to have that equation simplified down. That is the line of best fit. We're going to be using our graphing calculator to do linear regressions, and we will do that activity during class.